So we'll solve this one with elimination. That's good. I like elimination. They also call it addition because we're going to add these two together. Now because it is elimination, that means we got to eliminate one of the two variables. And it doesn't matter which one you choose to eliminate, so I'll let you choose. All right, now if we choose to eliminate the x's like we're going to, we need the coefficients to be opposites of each other. So right now they're the same sign, first of all, but they're also not the same value, right? So we need it to be the same number but opposite signs on that, which will, when we add them together, we'll eliminate them. Now what that means is I'm looking at both of the coefficients of x right now, right? Because we've chosen to eliminate that one. And I've got to force it almost like we would with common denominators to be the same but opposites, right? So I'd say, well, what's a common multiple of 4 and 3? And then, you know, if you came up with 24, that's just kind of bigger than we need. But 12 would work, right? So I'd say, I'm going to multiply the 4 by 3. Now, we can't just change the 4x into 12x and say, hey, we're good with that. We actually have to distribute the 3 to all of the terms in the equation. Otherwise, we've changed its actual value. So even though we're changing the way it looks, we're not changing its actual value. So 3 and negative 5y's would be negative 15y's. And then 3 and 6 would be 18. Now, I kept this one positive. I usually like, personally, the top one to be positive. I don't know why. I just do. So I'm going to make the bottom one the negative, the opposite, right? And to do that, I'll have to multiply it by negative 4. But again, we need to distribute into all three of the values. So this is going to change it into negative 12x. And then that's an x. Negative 4 times negative 4y is going to be positive 16y. Oh, this one's going to come out real nice. And then negative 4 times 4 is just negative 16. Well, once you get this, the coefficients of whatever variable you've chosen to eliminate to be opposites, then you just add the two equations together to make a new equation, but without one of the two variables. So 12x minus 12x, and we're going to add all three parts of this. That zeroes out just like we wanted to. It eliminates. And negative 15y plus 16y is 1y. And 18 plus negative 16 would be 2. Well, that coefficient of y is 1. If it wasn't a 1, though, I'd have to divide on both sides by whatever that coefficient was. So this tells us what y is. Y is 2, at least if we did the math right. So now we got to go back and we got to look at one of the two original equations. So we're choosing the top one. We're going to use the bottom one to check, to make sure that it maintains equality and truthfulness. And right here we're saying that we're going to replace the y with 2 because right now we think it's 2. And from here we can solve for its corresponding x value. So, multiply these together, you get 10. So now it's 4x minus 10 equals 6. And continuing to solve this equation, I would add 10 to both sides. So that zeroes out. We'll drop the 4x, now equals 16. And then finally, we'll divide both sides by 4. To make that 1x. So x equals 4. So this creates an ordered pair, like I showed on the graph, of 4, 2, which means if we graph those two equations, they should intersect at 4, 2. Now we know 4, 2 makes the top equation a true statement, but what about the bottom one? Well, let's just make sure, because if it makes it false, then we've chosen a point that's on one of the lines, but not the other. But if it's true for this one, then it's on both. So it's 4x. Oh, no, not 4x. I got 3x. Let's go back. (3x) minus 4y equals 4. And since we are checking this one, right now I'm just going to put a question mark over the equal sign so we know we're checking. So we know the x value and y value. X is 4. And the y value is 2. And we'll just check, right? 3 times 4 is 12, minus 4 times 2 is 8. 12 minus 8 is 4. You could just plug that into a calculator if you need to. But yeah, that shows that that statement is true. And we know it makes this one true as well. So, since it is true, it is definitely the answer for that one. Now, I did some checking on that one. We don't require it, of course, but I think it would be unwise to not check on a test or something like that, or quiz. So make sure you are checking those, but yeah, that's the elimination method, I guess, in a nutshell.